So color, I mean, previously we learned the vector, right? You know what? Based on the vector is absolutely most important thing for the designer. Yeah. So the second important thing, I guess, is the color, because we are dealing with like some 3D geometry or 2D geometry which has can be reflected the light, or we can define some color. Yeah. So with the vector and color, we can actually draw something on the screen. Not only screen, you can migrate the information from digital world to physical world by validate. Yeah. So the color is important. So there's many ways to emphasize, but one thing I wanted to mention is like a force color, right? So as a computational designer, I have several experience to make some optimization for the building energy or lighting simulation. So a lot of the industry like using this simulating their own environment like by computational methodology. So the force color is something like different types of representation of the data. Yeah, just like this is also sort of data visualization, let's say. Yeah, so because to think about it, we have some gradient like let's say 000 black, right? 252525. Let's say we can normalize like a 000 or 1.1.1, right? So in between, we can project, we can represent any other information in that scale, right? We call this normalization. So inside of this, let's say space 0 to 1. So in the using the force color, we have a more like a visual, distinction between this range, for example. So, I mean, there's a different types of color representation depends on the area. So one of my friends who work in the cosmetic industry, they have their own sort of. I couldn't remember the how they call the color, but the other day I had them to compute like a convert color RGB to their format, but I couldn't remember this. I couldn't sleep. Anyhow, so here we have a data structure to describe color. Yeah. So same as before, we have RGB. A stands for alpha, right? So you guys designer. Yeah? So I'm used to like a more not normalized value, it's like a 0 to 255, right? And RGB and alpha, usually alpha, we use the normalized value, okay? So this is the minimum requirement because we're gonna create a class, right? Class has need their own information. So we declare the sort of, we book the room in the hotel, for example, right? And then we ask some information, yeah? And then we bind them, yeah? This is a minimum requirement for the class because the constructor is always required to create a new class. And then other than that, they are sort of, let's say, custom function here, right? So normalized, this is function, which just belongs to instance, correct? And we have the other function called toHex, meaning that we can convert RGB value to the hex value that we already learned yesterday, right? And then also we have the other sort of function, looks a little bit complicated, but as I said, if the function is complicated, just looking at the two places. One place, what is the input values? What is the return value? That's it, yeah? So we just encapsulate the complexity inside of this function, right? And then the beauty of this way is also we can reuse because we modularized individual small logics, right? Maybe you can, on top of it, you can create the more complex logics that actually cook the small logic, correct? So in this way, you guys can have like a, actually, can make more work within in less time because we know we have a lot of like tools, a lot of library, let's say. So we can just simply assemble or disassemble based on the project or research, right? So here, what it does is we have RGB information because we ask the user to give the RGB value to create the class, which is a requirement, right? And then we have a multiple function to convert this data to the hex value, or hue saturation value, HSV, correct, right? So at the end of the this one, it has a return value here, just like this. And then 2hex has a return value here. Itself is return value because it's just function, yeah. And then normalized, this is also return value. Okay, but one thing I can tell you, maybe I'm just a little bit hesitating in my mind, but you know what? I have a question. So, do you think if I execute this function, yeah, is it really change the information or not? This is a really important question, actually. Yeah. To me, it's self-explanatory, but I'm just trying to ask you guys, like, make some brainstorming here. So we have this and red is red and green and B. So we simply use it in order to normalize, yeah, 0 to 1, and then we simply return it, meaning that the function actually never change the value inside of the class. So this is a really important thing because we're gonna make some agent-based system. So each agent talks each other, but sometimes they actually can change their own information. We need to create a rule, but on the other hand, maybe what if other agent can tweak the information the other agent? In this case, the logic is become crazy. So we need to make a very strict rule. Yeah, I mean as your experience is getting increased, you guys get like a try and error experience. So maybe for the instance class, I suggest you guys, for example, okay, we're gonna create a function that never tweak the information inside of the class. If you really want to tweak the information in that class, then we can using the static function, for example. I mean, this is sort of a rule. There's no like mandatory abstraction, I guess. But anyhow, so if I do like this, okay, actually I can give you the other code here for the brainstorming purpose. So let's say I'm going to keep it like that here. Yeah. So this function actually just use our own value, but we are not going to change. Just make some output. Yeah, and then we directly return the value. But in this case, I divide the number by 2555, meaning that because this is basically this one, the same operation. Same operation, yeah. So we calculate it, and then we overwrite this information to that one. So after this line, the R value is already normalized. Yeah. So we simply return it. So once we execute this line, we basically tweak this information. Yeah. However, if you execute this line, yeah. Oh, I think this is wrong. Yeah. I think that this is the correct one. Yeah. Now I just found it. Yeah. Because equal sign is assign something. So in this case, we never tweak this information. Yeah. I think this is good. Yeah. So anyhow, I create the. I think I need to get rid of this function because they have same name, which is no good. I save it. So you know, I create a color object out of this color class. Correct. The value is the lag value is the maximum. So as a hex value, it's like that. So you can make a double check. Yeah, this is lag color, right? And then okay. So you can go to this website in order to see what the result here. Yeah, here. So 011, right? Hue saturation value 011. Yeah. 0, 1, 1. Yeah, it's maximum value because this is normalized here, right? So they are basically same color but different representation. CMYK, HSD, HSL, LED. Yeah, this is LED color. So cosmetic area, they use the lab types of representation of color. Yeah, anyhow. So yeah, play with this information and functions and then create your own color class. Yeah,